Welcome back to the session. Today in this session we will be solving moment of inertia of L and channel sections. So let us get on with the first numerical. Find the position of center of gravity, moment of inertia about Ixx and moment of inertia about Iyy for an unequal angle 125 mm into 75 into 10 mm thick. So if you read as an unequal angle, this means that it is a L section. So for this L section, dimensions are given as 125 mm. So 125 mm is its longest length here, and 75 mm is its base, and 10 mm is its thickness. So first we are asked to find number 1, position of center of gravity. Center of gravity. Position of center of gravity. Now what is this position of center of gravity? It is for x-axis it is x bar, and for y-axis it is y bar. Now for this L section here, when we find moment of inertia about x-axis and y-axis, along both the axes we have to use parallel axis theorem. Okay, now if we are to find position of center of gravity along x-axis, which is x bar, will be equal to a1 x1 plus a2 x2 divided by its total area, which is a1 plus a2. So let us first find areas. A1 will be equal to, let me name this as section 1 and this as section 2, right? So my A1 will be equal to 75 into 10, which will be coming equal to 750 mm. My area to A2 will be equal to, now I need only this length, so the total length here is 125, so 125 minus 10 is, this length will be equal to 115 mm, right? So my area 2 will be 115 into 10, it will be coming equal to 1150 mm. So this is my area. Now if I have to find x1 will, for the first section here, will be, let me just draw it here, will be x1 for this section here will be half of this section. Half of this section, this much, will be my x1. This will be my x1. And for the section 2, half of this, only the half of this section till here. So this much, half, will be my x2. I hope it is clear, x1 and x2. So for my x1, what do I get? x1 for this base section, which is half of this base, will be equal to 75 divided by 2. It will be coming equal to 37.5. It is 37.5 mm, right? Now my x2 similarly will be equal to, now this x1 of from this section x1, from this section x1 and this section x2, x2 will not be dependent on x1 of this section 1. So it will be independent because it is a total base. So for x2 it is only 10, so it will be 10 divided by 2. So it will be 5 mm, right? Now similarly if I find y1 for this section, it will be half of this section, right? Only half of this section, which will be equal to 10 by 2. This will be coming equal to 5 mm. And y2 will be, now for this section 2, y1 will be dependent on this y2. So when I go in this direction, this is in vertical direction. So when I go, I have to add the vertical distance of this section plus half the vertical distance of this second section. So half of this will be around somewhere around here, right? Let us consider somewhere around here. So it will be how much from this point till this point will be my y2. So it will be coming equal to 10 plus 115 by 2, right? So if I calculate this one, this will be coming 2, 5 is 10, then 2, 7, 14.5, right? So it is 57.5 plus 10 will be 67.5 mm. So we got both x1, x2, y1 and y2. Now let us find x bar. X bar will be equal to area 1 is 750 into x1 was 37.5 plus area 2 was 1150 into x2 is 5 divided by the total area 750 plus 1150. Now let us see how much we get. X bar will be equal to, let us solve it in a calculator. So it will be coming equal to 750 into 37.5 plus 1150 into 5 divided by the total area, which is 750 plus 1150. So this is coming equal to 17.83. I'm converting this 2 to 3, so it will be 17.83. 17.83 mm. So this is my position of centroid for x-axis. Now let us find for y. So for y bar will be equal to a1 y1 plus a2 y2 divided by its total area a1 plus a2. Now how much is my area 1? A1 is 750 into y1 was 5 plus a2 1150 into y2 was 67.5 divided by the total area, which is 750 plus 1150. Now let us solve this in a calculator and see how much we get. I'm just gonna change the values of x1 and x2 here and make it to this one. Here is y2 is 67.5 and here it is into 5. So I'm getting equal to 42.83 again. So this is coming equal to 42.83. 42.83 mm. So this is the position of my centroid for y bar. So let us, if we find this position here, if I find this position here, so from x bar it was coming 17.83. If this much is my 10 and half of 75 is 37.5, so let us say that it is lying somewhere around here, my x, somewhere around here, okay, and y bar, I'm saying from here to here, y bar is coming 42.83. So if this is my 10 and this is 115, half of 115 is 57.5, half is here will be 57.5, so it is coming 42.83. so somewhere around here, right? So if I delete this and my x-axis will passing from here, and y from this point here. So this point here is the centroid G. This distance here is my y bar distance, which is 42.83, and this distance from here to here is my x bar distance, which is 17.83. So this is the position of centroid. Okay, now let us find Ixx and Iyy. So number 2, moment of inertia about Ixx axis will be equal to Ixx will be equal to Ixx1 plus Ixx2. 1 and 2 for this section number 1, Ixx1 of this section number 1 here, and Ixx2 of this section here. Okay, so I have to use the parallel axis theorem here. So for Ixx1, the formula will be BD cube by 12 plus area 1 A1 into H1 square. So this is for Ixx1, and for Ixx2 it will be BD cube by 12 plus area 2 H2 square. Now my H1 and H2 here, H1 will be equal to, since it is across XX axis, it will be equal to y bar minus y1, and my H2 will be equal to y bar minus y2. So let us find B. Now how much is my B and D? B here, for this my first section here, B is equals to 75 and D is equals to 10, right? And similarly here for my second section, B is equals to 115 and D is equals to 10, right? So for the first section I have B equals to 75 into D is 10 cube by 12 plus the area for A1 was 750 into, now H1 is equals to y bar minus y1. So y bar was equal to 42.83 minus, how much was my y1? Y1 was equals to 5 the whole square, right? So this is for my Ixx1. For Ixx2, B was equal to 10 and its depth, and the depth was equal to 115 cube by 12 plus area 2 was equal to 1150 into y bar is 42.83 minus y2 was equal to 67.5. 67.5 the whole square. Bracket close and bracket close here. Now let us find this value in calculator. (75) into 10 raised to power 3 divided by 12 plus 750 into 42.83 minus 5 the whole square. So this is coming equal to 1.08 into 10 raised to power 6. 1.08 into 10 raised to power 6 plus ixx2. Let's find ixx2 as well. 10 into 115 cube divided by 12 plus 115 into 42.83 minus 67.5 the whole square. So this is coming equal to 1.97. 1.97 into 10 raised to power 6. Now its total will be plus 1.08 into 10 raised to power 6. So this is its total. It is coming equal to 3.05 into 10 raised to power 6. 3.05 into 10 raised to power 6 mm raised to power 4. So this is my moment of inertia about ixx axis. Now the third one, let us find. Third one, moment of inertia about Iyy. Okay, so about Iyy, again I have to use parallel axis theorem here also. Iyy1 plus Iyy2. So here Iyy1 will be db cubed by 12 plus a1h1 square for Iyy1 plus here it will be db cubed by 12 plus a2h2 square. So this is my second one. So d depth here for the first section was 10 and its width was 75 cubed by 12 plus area was 750 into, now here h1 will be equal to x bar minus x1 for y, right? h2 will be equal to x bar minus x2. So here it will be equal to x1, x bar was coming, how much was our x bar? X bar was 17.83 and x1 was 37.5. So 17.83 minus 37.5. 17.83 minus 37.5 the whole square, right? So this is for my Iyy1. For Iyy2, its depth was 115 and its width was 10 cubed by 12 plus its area was 1150 into h2 is equal to x bar is 17.83 minus x2 was equal to 5. So it was equals to 5 the whole square. So let us solve this. I'll do it directly here. 10 into 75 cubed by 12 plus 750 into 17.83 minus 37.5 square. So this I'm getting this much. So I'll directly add it up. Plus for Iyy2 115 into 10 raised to power 3 divided by 12 plus 1150 into its height 17.83 minus 5 the whole square. So I'm getting total 840.6 3. It is coming 840.63 into 10 raised to power 3. So if I move this decimal point here, it will be coming equal to 8.406 into 10 raised to power, since I have gone 2 decimal fronts, so it will be 3, 4 and 5. 10 raised to power 5 raised to power 4. So this is my moment of inertia about Iyy, and here I have moment of inertia about Ixx, and these are my centroids. I hope this numerical is clear. Now let us solve the second numerical. In here we have a channel section here, and for this channel section the dimensions are all given, and according to the dimension we have to find moment of inertia about x-x axis and y-y axis. Now when we solve channel sections, you have to know along which direction we have to use parallel axis theorem and along which direction we can just normally find it. Now if you look at this section here, my x-axis is going horizontally like this, right? And my x-axis is 90 mm here, 90 mm, and my y-axis is this vertical. It is going vertically, and vertically along vertical distance I have a 50 mm length running vertically, right? So this is my y. Now comparing these two lengths, x-axis is having larger length than as compared to the y-axis here. So along, when we find moment of inertia about x-x axis, we have to use parallel axis theorem along x-x axis. Now if let's solve it. Number 1, moment of inertia about x-x axis. Okay, so here Ixx will be equal to, now let me divide this section as 1, 2 and 3, right? So I have Ixx1 plus Ixx2 plus Ixx3, right? Now I need to know this height here. This height from here to here will be equal to 50 minus 10, so it will be equal to 40 mm, right? So since I have to find with parallel axis, I need to find a1, a2, y1, y2 and y bar, right? So let us first find a1. A1 for the first section will be 90 into 10 will be coming equal to 900 mm square. Now for A2 and A3, since the section dimension is the same, we'll get same area. So A2 will be equal to A3 and it will be equal to 40 into 8. It will be coming equal to 320 mm square, right? Now let us find y1. Y1 for this section will be half of this section, which will be equal to 10 by 2 equals to 5 mm. Now y2 will be equal to y3 again, since the height of y2 and y3 is the same, so I need to find till half, right? Till half of this y2, right? But I need to go from this distance here till here. So I have from here to here it is 10 and half of 40 here is 20. So I have 10 plus half the distance of section 2 and section 3, and it will be giving me 30 mm, right? Now we have found out y1, y2, a1, a2. Let us find y bar. So now my y bar will be equal to a1 y1 plus a2 y2 plus a3 y3 divided by the total area a1 plus a2 plus a3. Now since my a2 and a3 are the same, I can do 2 into. So I'll show you how. A1 is 900 into y1 is 5 plus, since the value of a2, a3 and y2, y3 is the same, so I can multiply it twice. 2 into a2 is 320 and a3 is also 320 plus into 30 its distance, divided by 2 into the area 320 twice, right, plus a1 is 900. So how much we get? Let's see. My calculator. 900 into 5 plus 2 into 320 into 30 divided by 2 into 320 plus 900. So this is coming equal to 15.39. So this is coming equal to 15.39 mm. So this is my y bar. Now let us find ixx1, 2 and 3. So my ixx will be equal to, for ixx1 I need to find bd cube by 12 plus a1 h1 square, parallel axis theorem, right? And for 2 and 3 we can do multiply 2 into, since it's all the dimensions are the same, bd cube by 12 plus area 2 and area 3 into h2 and h3, all of them will be same, coming same, so I'm multiplying it with 2. So my here h1 will be equal to y bar minus y1, h2 will be equal to h3 will be equal to y bar minus y2, or it can, this y2 can also be y3. So I get the same value. Now b here for my first section is 90, depth is 10, cube divided by 12 plus area is 900 into height, y bar was 15.39 minus y1 is 5 square, right? So this is my first expression plus 2 into, now b, how much is my b here for section 2 and 3? It is 8 and depth is 40. So b is 8, depth is 40, cube divided by 12 plus its area was 320 into y bar is 15.39 minus y2 and y3 was coming 30. So 30 square. So let us find this. It will be coming equal to, I'll first find the first x2 and 3. I'll do 2 into, okay, bracket open, 8 into 40 cube divided by 12 plus 320 into 15.39 minus 30 square. So I'm getting this, and this is coming equal to 221.94. So let me add this plus ixx1 is equals to 90 into 10 cube divided by 12 plus 900 into 15.39 minus 5 the whole square. So I'm getting, this one is coming equal to, so altogether I'm getting 326.59 into 10 raised to power 3. 326.59 into 10 raised to power 3 mm raised to power 4. So if I convert this approximately, if I move this decimal point, it will become 3.2659 into 10 raised to power, since I went 2 decimal point ahead, 10 raised to power 5 mm raised to power 4. So this is my Ixx. To find Iyy, I will convert this U channel section into a hollow rectangular section. So how can I convert this a hollow rectangular section? I'll draw an imaginary line running from here. I'll draw imaginary line running from here, and let me name this as P, Q, R, S. This is my outer rectangle, and for inner, from this point A, this point B, here C, and this point as D, right? Now I need to find this distance from D till C, right? So my distance from D till C will be equal to 90. Its total length is 90 minus, I need to minus this from here to here, and this thickness from here to here, which is 8 plus S, 8, 16. So I have 16. This will be coming equal to 74 mm, right? So I have this distance also. Now let us find Iyy. So my Iyy now will be equal to moment of inertia of the outer rectangle, which is, let me write this as a capital D, capital DB cube by 12 minus small letter dB cube by 12. Now this capital dB cube by 12 signifies the outer rectangle, and this one inner rectangle, right? So what do I have? If I take common out as 1 by 12, the formula becomes dB cube minus small dB cube, right? So it will be equal to 1 by 12 into, how much is my D for the outer rectangle? D is 50 and B is 90, right? 50 into 90, outer rectangle. And for inner rectangle, my D depth is 40 and its B is 74. 40 and 74 for inner, 50 and 90 for outer. So my depth is 50 into 90 cube minus, here for the inner rectangle my depth was 40 and its width was 74 cube. So let us see how much we get. It will be equal to, let's solve with a calculator, 1 by 12 into 50 into 90 cube minus 40 into 74 cube. I'm getting this equal to 1.69 into 10 raised to power 6. 1.69 into 10 raised to power 6 mm raised to power 4. So this is my moment of inertia about Iyy. So for channel section we have found moment of inertia about Iyy and Ixx. So this is your U channel section. I hope this numerical is clear. So coming to the last numerical for today's session, let me read its statement. Find Ixx and Iyy for the channel section with the following dimension: flanges 50 into 100 mm. So I have this flanges is equal to 50 mm into 50 mm into 10 mm. So here is also 10 mm its depth, right? And overall depth is 200 mm. So this is my overall depth, which is equals to 200 mm, and thickness of wave is given 10 mm. So this is given. Now we are asked to find moment of inertia about I xx and Iyy. Now looking at this again, you have to find out along which direction you have to use parallel axis theorem. Now this is my y-axis, this is my x-axis, right? X-axis is running horizontally, y-axis is running vertically. Now my vertical distance here is 200, and then my horizontal here along x-axis is 50 only. So 200 is more than 50, so we have to find parallel axis theorem along y direction because 200 is more than 50. Now let us solve. Let me first find Ixx, moment of inertia about xx axis. So my Ixx will be equal to, let me convert this section into a hollow rectangular section, since I don't have to find parallel axis theorem along, I don't have to apply parallel axis theorem about Ixx. So I'm converting this into hollow rectangular section. I will be naming this section as A, B, C and D, and this inner portion E, F, G and H. Okay, now if I, and let me name this section here already. Let me name this as 1, section 1, 2 and 3. Now let us just find moment of inertia about xx axis. So here, since I have made this C section into a hollow rectangular section, all I need to do is find moment of inertia about its external rectangle, which is 1 by 12. Formula is 1 by 12 BD cube minus small bd cube. This is my formula, right? So just applying the formula, 1 by 12 into B for this section, outer rectangular section, is 50. B is 50. Its depth is 200. So 200 cube minus, for now inner rectangle, I need to find B from here to this point, right? So how much is my B? Total here is 50 and its thickness is given 10. So 50 minus 10, I have 40 mm. This is my B. Now depth, I need to find from this point till this point here, my D, small d. So how much will it be? The total is given 200. So 200 minus 10, this depth here is 200 minus 10, it becomes 190. 190 minus this depth here, 10, will give you 180 mm. So your small d is 180. Your B is 40 into D is 180 cube. So let us find Ixx. It will be coming 1 by 12 into 50 into 200 cube minus 40 into 180 cube. So my Ixx is coming 13.89 into 10 raised to power 6. 13.89 into 10 raised to power 6 mm raised to power 4. So this is my moment of inertia about Ixx. Now I have to find about Iyy. To find about Iyy, it will be equal to Iyy1 plus Iyy2 plus Iyy3, and along this direction I need to use a parallel axis theorem. So before I find parallel axis theorem, I need to find x bar, right? X bar will be equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So this is my total area. So I need to find a1, a2, a3, x1, x2, x3 to find x bar. So let us find one by one. My a1 for this section. Now as you can see, my section 1 and section 3, they are of the same dimension. So a1 will be equal to a3 will be equal to 50 into 10. So this will be coming equal to 500 mm square. So this is my area. Now a2 will be equal to only this much. I need to take only the area of a2 section, which is this much. So this will be equal to, its depth is 180 into, and its width is 10. So this is will be equal to 1800 mm square, right? So I've got my area. Now let us find x1. Again, x1 will be equal to x3 because it is having the same dimension. So x1 will be equal to x3 and it will be equal to 50 divided by 2. So this will be coming equal to 25 mm. And my x2 will be equal to x2, the width of x2 running along x direction is 10, right? So it will be 10 by 2. It's coming 5 mm. Now we can easily find x bar. So x bar will be equal to, area 1 is 1800. Now since I have x1 and x3 is equal to same, this x1 and x3 equals to same, its dimension is same, I can do 2 into, let me rewrite this again. So it will be 2 into area is 1800 into x1 and x3 is equals to 25. So I do it directly since my a1, x1, a3, x3 the values are same, plus area 2 was, oh I'm sorry, this is not area 1, a1 would be equal to 500 only, 500 area 1. Now area 2 is 1800 into x2 is 5 here, divided by the total area 2 times 500 plus 1800. So let us see how much we get x bar. Two times 500 into 25 plus 1800 into 5 divided by 2 into 500 plus 1800. So this is my x bar is coming equal to 12.14. This is coming equal to 12.14 mm, right? Now I can directly find Iyy. Iyy will be equal to, since my Iyy1 and Iyy3 will be same, so I'll do 2 into db cube by 12 plus a1 h1 square, right? So this is for both Iyy1 and Iyy2 plus Iyy1 and Iyy3, and I have Iyy2 db cube by 12 plus a2 h2 square. Now my h1 will be equal to x bar minus x1, h2 will be equal to x bar minus x2. So let us put all the values. Now for depth for this first section is 10 and its width is 50. So I have 10 into 50 cube. And similarly for the second one, I have depth is equals to 180 into 10 cube. So let us write it here. 2 into its depth here was 10 into b was 50 cube divided by 12 plus its area was 500 into h1 is x bar was equals to 12.14 minus x1 was 25 square plus, now for the second section, my depth was 180 into b was 10 cube divided by 12. This is for the web portion. Plus area was how much? 1800 into x bar is 12.14 minus x2 is 5, the whole square. So let us solve here further in the calculator. It will be coming equal to 2 into 10 into 50 cube by 12 plus 500 into 12.14 minus 25, the whole square. So this is my IYY 1 and 3 plus 180 into 10 cube divided by 12 plus 800 into 12.14 minus 5, the whole square. So I'm getting total, I'm getting 429.49. So it is equal to 429.449. It is not 49 into 10 raised to power 3, right? So if I raised to power 4, so if I just take this decimal point, it will be 4. I'm sorry, here again. It will be 4.29 into 10 raised to power 5 raised to power 4. So this is my moment of inertia about IYY for a C channel section. So we have found both the moment of inertia about both the axes, and this is it for today's session. I hope all the numericals are clear. See you again in next session.